talking with you guys. So yeah, no, I'm gonna show you today how to use a for loop in C#. And it's just like a for loop is a very conventional structure in any programming languages. It loops through a statement and does it over and over again, basically. But it turns out that C# actually does not have this for loop structure, as it's called, because actually I don't know why Microsoft decided to not put that in. But today we're going to figure out how we can actually program a for loop ourselves in C# and use it. So we'll start off in our favorite, or my favorite IDE anyways, which is the short term for Integrated Development Environment, the Word. And to start programming with this, click up here on Developer, and then you select Visual Basic, my favorite programming language, and it opens another window. And here we can actually execute and write our code. So we click on this document, which opens our code window as it is, as you probably know because you've seen this development environment like a million times already. It's the most used development environment in the world, so I mean I don't gotta explain what any of this does. So yeah, the first thing that we're gonna do is declare write our code that does a for loop. So bear with me for a second while I do that. And here we are. This code loops from 0 to 10, as you can see here. For I equals 0 means the variable I starts at 0 and it goes to 10, and it shows a message every time it loops this code with the current variable contents of I. And we can see how that works, what that amounts to in generated code if we click this button up here. And it starts message 0, message 1, message 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then it ends. Exactly how we wanted it to happen. So here we are in Microsoft Visual Studio, which is basically a better Word development environment that came out this year. This is called Microsoft Visual Studio 2017. Before that, Word was obviously the best thing to use, but yeah, they've updated it. It looks a little different now. You can still write your documents in here, And the first thing we're going to do is create a new project, and we want to do a console application. Just trust me with this. You enter any name you want to. I just, based on the topic, I entered for loop, and we don't need any of this shit. Fuck, Jesus Christ! No, just stop. Okay, and yeah, so this is what the IDE comes up with. A little bit of code that we already have, so we don't have to write that submain that we did before. And yeah, so we actually need to do another thing, that is add another project to our solution, because we need to have two projects. The first one is going to execute or run our code. Basically this is where the program will enter. It starts with main and then does whatever it finds here. And the other one is going to actually be the code for our for loop. So we're gonna add another project, and this time we're gonna not use a console but a class library, because we don't want to output anything in our for loop code itself. We want to do that in our program. And I'm gonna name this for with a 0 because that's cooler. And then we're gonna delete this right here. You don't need that. So yeah, that's the first step. So the first thing we actually want to do when we start programming is connecting the two projects with each other. To do that, we want to find out which project uses which project. And that is very simple. The for loop project uses the for project. So we go in here, reference it, add reference. And if you're not already in this part of the dialog, click project and solution, and then check the for and click OK. Once you've done that, it will appear in this list, which you can close. You're done with that, and then we can actually start programming. Right click the project, add, and select class, because we want to program a class, and name it something. I don't really care, and we'll make it public because we want to access it from the other project. And we also add a method to it, which is called something like looper, and we add arguments to this method. Well, we want to start somewhere, we want to end somewhere, and we want to step up the counter at some variable. and we want to execute some code. There we go. This is what the method will look like. The for loop starts somewhere, it ends somewhere. Every step it adds a specific value to the counter, and then it executes something which is contained in this object right here called an action. So we go back to our program, and we can actually call this code now. Type for, and then we select class and looper. No, you might actually want to rename that. Call this looper, this loop. Sounds better to me. Looper, loop. There we go. And we want to start at 0, go to 10, step up 1 each time, and then this is where our code is going to be. Our variable is called I, as it's basically the same as we did in Visual Basic, because this is also called I. This is our counter that comes up. The I is just, you know, it's a programming thing. It's for languages that can actually do the for loop. This is called I every single time. And if you do it differently, you're not a real programmer. So we want to output this I variable just so we know it's working with the console write line. And there we go. This is going to output the contents of this variable every step of the way. Now we can actually start programming our for loop. We'll start with adding the state of the for loop, because every for loop has a state which contains the current, well, counter. So we do that here. And we'll start at 0, but this, you know, we can start at any given variable for start. This is just, you know, how many times the loop is executed, not the actual contents of the I variable. And we calculate the current state, what I just talked about, at the start. So, you know, how many times has the loop run, plus our start variable. That is the current state. And then we check if state is smaller than n, meaning it has not reached the end yet, do something. And what we'll do is we execute the body, which is fairly simple, with the current state, giving it the information about, you know, what is currently running. So you think, okay, that all looks good, right? It's running, so we can actually see what is happening currently if we start this. And after it's built, after it's done, at some point in the future, it'll show us this. Oh, and it's over. Why is that? Well, because we didn't hold Control and press F5. And there we go. This is not what we want though. We actually want it to loop from 0 to 10. This is just following 0 and then it's done. So why is that? Well, because it never increments this. So we need to do that. But this is not the same program as this. And, you know, C# is a structural programming language, so you do not want to alter the state. That's why this is a const. Meaning we have to do this in another way. How do we do it? Well, it's fairly simple actually. We execute a different executable every time this loop runs. Therefore we are not changing any variables in the state of the executable if we are just running different executables every time. That is also the reason why C# does not come in stock with a for loop, because a for loop is going against its principles, the, you know, functional programming. So let's start here and with the actual implementation of what I just talked about. So in the first run, the executable doesn't know where it is executing from. Therefore, this is, you know, empty. So if it figures out that, okay, currently I don't know where I'm executing from, it tries to figure that out using this code. So it gets a stack trace. A stack trace is basically a list of functions that are currently running or got the program to this point. And we're getting a specific part of the stack trace which we can use to get the current executing name from. So I can show you what that looks like, which with a little debugging. You put a breakpoint here and restart the application. and it'll break that location. So getting the current stack looks like this. Let me get that over. Looks like this. We'll see that there's we currently in get stack trace, then get stack trace, and then this is the loop, that is this function, then we get the program main, and so on. And for us, the important part is this line right here, which is where the current code is executing, right there. Because we want to actually get a certain part of this, which is this part of it, which is the current file that the code is executing in, this class1.cs. So we get that with a little, string split magic right here, and we get the path in path. Where's that? Right here. So that is the file system path to the file we're currently editing. And then it does a new path for this, and so on. And then we put the next part afterwards. Another thing you have to notice that it puts a warning right here, unreachable to blah blah. It doesn't matter. It's just a warning. It's not an error, guys. You don't need to worry about that because it still will compile and run, as you could just see because I just did it. So you can ignore any warnings in your code anyways. So yeah, let's get on with it. And in this part, we'll actually see the meat of the application, the how the sausage is made. Because here we increment the state by the step variable, and we copy the contents of the file we're currently in into a temporary location, which is new path. You see right here at plus temp to the path, and then we get the contents of the new file, which we just created with all this stuff in here. And then we replace the current state, which is the for loop state equals and then something which is in here. Replace that in the file with the new state, which is for loop state equals new state dot toString. New state is what we just created here, which is the next state. And we also tell the application or the file that where it's running from. So we don't need to do this every time. And we do that here. It replaces the exit path with the current path that it knows. And then we write the new contents to our new file. So the next step is to actually use this file to create an executable, not executable, but a library file, .dll, and to link that to our program so it executes not this but the actual next step of the file. So we do that now. And here we are with our new code, which basically just compiles the file we just created with this code into a library file, as I just said. So we're gonna get a C# compiler instance in our code, which is, it represents the csv.exe file you all know about, and it has a few parameters. For example, that it shouldn't generate the new DLL in memory. It actually output it, it puts it somewhere, which is actually right here, which the current assembly execution path, and we add a 1 to at the end so we don't override our old assembly. And we also don't want an executable, we want a library file. So that's what these three parameters do. Then we get the .NET Framework path, where the current .NET Framework is installed, and we use it to add a few reference assemblies to our C# compiler provider. We need these to in our code to reference certain parts of Microsoft's code. For example, the Microsoft C# DLL is used for these to use the C# compiler in C# code, and systemdl contains some vital parts of the C# language, like file or lists and stuff like that. And then we actually compile it just using this compile assembly from file, and we use the parameters we declared here and our file, which is the new path which we declared up here. And once we've done that, we get a result from that which will say, you know, that this worked, this didn't work, and we'll use with that to, you know, work with that. And the last thing you need to do is hot swap the library we use to execute this very for loop with, you know, our new library file that we just created. So let me code that real quick and we'll go over what that code does. And here we are. So yeah, as I said, this is just going to load our assembly right here. So we declare the as, and then this as takes the load right here, and then at the end we delete the file that we just created because we don't need it anymore. We can do this. Usually if you would load an assembly and try to delete the file, it wouldn't work because it's still in use, but we use a trick to work around that problem, and we do that by actually just reading the bytes into a buffer, all the bytes of the assembly, just like, you know, you would read a normal file, and then creating assembly from that bytecode instead of actually, you know, linking the assembly to our code. So now we have this assembly loaded, we delete the old file, and then we just, you know, sort of pick into the code of the new loaded assembly, and we invoke the loop method, which is this right here that we're currently in, with the start, end that we, you know, the parameters that we pass in here as well, start, end, and the step, and our body, which is, you know, the code that we want to execute from here, this part. And once we've done that and the code executed, because this waits until the loop completes, we delete the file if we are in the topmost, you know, topmost loop. So it clears up everything that it created. So at the end there's no litter left on your hard drive, like, you know, multiple DLL files or something like that. We don't want that, so we clean that up afterwards. And yeah, this is all the code. This is all that is needed for C# to actually have a for loop that it didn't have before. So we can use this along the other loop types that C# has, which is, you know, do loops and while loops. So one last thing you have to do is when you scroll up, you see that there's a lot of unused references here. You need to actually remove this by right-clicking and remove stored and using, or remove them yourself, you know, if you're pleb. And then it will actually run. So we'll see that right now. We click on program, and this should, you know, output the numbers from 0 through 10. So both of those included 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll see if that works. Clicking on start. And yes, it actually does. If you were quick on your eyes, you saw that it started with 0, ended with 10, and then closed the application exactly as I wanted. Thank you for watching. I hope you've found this tutorial a little bit helpful, so you can actually use the very, you know, useful for loops in C# in the future. Thank you very much, and bye.